Principle number 4 looks at the second derivative, if you want, of bonds. What principle number 4 says is that the sensitivity of a price of a bond to changes in the yield to maturity is increasing at a decreasing rate with the length to maturity. Okay, that's a pretty complex sentence, so let's read it again. The sensitivity of a price of a bond to changes in the yield to maturity, let's stop here. This is what we saw in principle number 3. How prices change with accordance to the yield to maturity. We already saw in principle number 3 that prices change according to the yield to maturity, and they are more sensitive with long-term bonds. That's fine. That's principle number 3. But principle number 4 says, okay, they are increasing, but they are increasing in a decreasing rate when the bond's length or time to maturity is getting bigger and bigger. So that's actually a second derivative of the bond's price. But we're not going to take derivatives. What we will do, we will measure the changes in the changes. How the changes themselves change over time. Let's do that. Here is the same principle, the same example as before. Let's see the numbers. In the upper panel, I just expanded the same panel that we saw, the same table that we saw in principle number 3. In other words, we take a $1,000 par value bond with different years to maturity, different yield to maturity, $100 coupon rate, $100 coupons or 10% coupon rate. And inside the table, once again, I'm recording the prices of those bonds. Once again, not surprisingly, you can see $1,000 right here in the middle, simply because with a yield to maturity of 10%, coupon rate of 10%, the price is always equal to the par value regardless of the number of years until maturity. I just expanded the table number 3 from principle number 3. All right, what I'm going to do in the lower panel is I'm going to measure changes in those prices between two pairs of two short-term maturity bonds and two long-term maturity bonds. So the gaps between 10 and 5 years to maturity bonds will be in this row, which means $171 is the gap, the change in the prices between two short-term maturity bonds. $171 you get by subtracting $1,219 from $1,390. $71 you receive by subtracting $1,103 minus $1,174. Actually, the opposite, $1,174 minus $1,103. 0 is obviously 1,000 minus 1,000. Minus 50 is 859 minus 909. And minus 83 is 745 minus 822. 30 minus 25 are the gaps, the differences in prices between two long-term maturity bonds. Once again, $64 you receive by subtracting 1,709 from 1,773. And so on and so forth. So the lower panel will measure for us the changes in the prices, how changes in prices occur between two short-term maturity bonds and two long-term maturity bonds. And then I will plot the lower panel, the rows on the lower panel. And this is what we get. On the vertical axis, you have here not prices, but differences in prices, changes in prices between two short-term maturity bonds and two long-term maturity bonds. On the horizontal axis, you have the yield to maturity. As you can see, once again, the slope here represents the sensitivity. And we already know from principle number 3 that long-term maturity bonds, their price is more sensitive to the yield to maturity. That's fine. That's principle number 3. But principle number 4 reveals us something new. It tells us that the changes themselves, the difference between two short-term maturity bonds is actually more sensitive to two long-term maturity bonds. The difference between the prices of two long-term maturity bonds. So let's stop here and let's understand what does it mean. Principle number 3 says prices are more sensitive to yield to maturity for long-term maturity bonds than short-term maturity bonds. That's fine. This is very intuitive. Long-term bonds are more risky. Prices there are more sensitive to short-term bonds. But principle number 4 tells us that this sensitivity is decreasing over time, which means for two long-term maturity bonds, the difference between two long-term maturity bonds is less sensitive than the difference between two short-term maturity bonds. Why is it important to us? The way bondholders choose their bonds to pick and eventually invest is the following. First, they decide what kind of investors are we. Are we more risk-averse investors or less risk-averse investors? If we really hate risk, then we will prefer to invest in short-term maturity bonds rather than long-term maturity bonds. Why is that? Because short-term maturity bonds are safer. They are not as risky as long-term maturity bonds. So that's the first thing. You decide which kind of bonds do you want to pick, short-term or long-term. You will pick short-term if you are more risk-averse, you hate risk, you would like to avoid risk, you prefer things that are safer, low risk, low return, low yield. If you prefer to take more risk, higher return, higher yield, you will choose long-term maturity bonds. That's fine. The second stage is to do the fine-tuning, is to decide, okay, now that I understand that I'm interested in long-term or short-term maturity bonds, I need to actually choose. Do I need to choose the 10-year, the 5-year, or do I need to choose between the 30 years bond or the 25 years bond? What principle number 4 tells you is that if at the beginning you selected short-term maturity bonds, you really need to devote a lot of time to select the specific bonds that you're interested. Because any mistake here between 5-year or 10 years maturity bonds is going to cost you dearly. You're going to pay through the nose if you will make a mistake here, and then something bad will happen, because the gap, the differences in prices can be big. The difference in prices between 5-year and 10-year. However, if at the beginning you selected two long-term maturity bonds, then which one is really not that important? The difference between two long-term maturity bonds is not that much. The difference here is pretty minor here, and it's not that important. So principle number 4 is important for the fine-tuning, for the stage that you actually need to select which kind of bonds you are interested to invest in. That's principle number 4. Principle number 5, it's a very simple principle, but in fact it's very powerful. So let me explain that. Principle number 5 says there is a linear relationship, a straight line relationship between the bond's coupon, C, and its price, P. Now we're measuring the relationship, the price of the bond and the coupon of the bonds, C. The principle number 5 said there is a straight line relationship, a linear relationship. And this is something very easy to observe straight from the equation. All you need is just to take C, the coupon, and take it outside of the brackets, outside of the summation. Because C is fixed, it's a fixed number, for example, 6%, $60, or whatever it is, all you need is just to take it outside of the brackets. What you're left inside the brackets is the following. The slope will be the sum of 1 over 1 divided by 1 plus the yield to maturity to the power of t. This is the slope. And the intercept, which is completely unrelated to C, to the coupons, is the par value divided by 1 plus the yield to maturity to the power of n. This is the straight line relationship, the linear relationship that you can see. The price of the bond is the slope that you can see here after taking C outside of the brackets. So you're left with the slope times C plus the intercept that has nothing to do with the coupon. That's why this is a straight line relationship. If you will plot it, this is what you will get. Bond price as a function of the coupons. A here is the slope, B here is the intercept, where you can see the interpretation. This is the slope, the sum of the reciprocals, the 1 over 1 plus the yield to maturity to the power of t. while the intercept is simply an independent term that does not contain C. It has nothing to do with the coupons, which is simply the par value discounted to present time or divided by 1 plus the yield to maturity to the power of n. This principle is very, very simple principle to understand and also to practice that. And it's also very powerful simply because we can do money with that. In the following example, we're going to try and make money using this principle. Let's see how to do an arbitrage using bonds. But before we'll do that, let's understand first of all what's the meaning of the word arbitrage. Arbitrage, it's a finance concept that says risk-free money, risk-free return. It's basically free lunch. Everybody likes to do that. If you see an opportunity to see arbitrage, you need to do two things. First of all, give me a call, so I will also know about it. And second, do it as quickly as you can with as much money as you can. Because it's free lunch. You're making money out of thin air, out of nothing. You're taking absolutely no risk and you create money. You make positive return, a profit, out of nothing. Everybody likes to do that, and usually arbitrage opportunities are disappeared in a matter of seconds. Why? Because all kinds of hedge funds and financial institutions and private investors also are running computer algorithms always to search for arbitrage opportunities. Whenever they detect that there is an arbitrage opportunities, they jump on it. They don't walk, they run. They jump on it like crazy because that's free lunch. This is making money out of nothing. And because of the market forces will make the arbitrage opportunities disappear. They will eliminate them, and it's going to take a matter of seconds. Maybe 1, 2, maybe 3 seconds, and that's it. When everybody sees something like that, everybody jump on that, and the market forces will eliminate that. We're going to see a couple of examples for arbitrage in this course, and this is the first one. Usually arbitrage is done by closing a circular deal. You buy something and then you need to sell something. It's not enough to take half a deal, to do only half of the deal here. You don't just buy something and then wish for that the price will go up, or sell something and wish that the price will come down. You need simultaneously to buy something, sell something that replicates the same cash flows of the things that you bought. But if you sell it at a higher price than the price that you paid when you bought, then you end up with a positive cash flow right now at time 0, and all future cash flows will disappear. This is usually the way to do arbitrage. So let's see the following example, and let's learn how to do arbitrage using bonds. Let's assume that we have 3 bonds. Let's call them A, B, and C. All of them have the same par value of $1,000. All of them have the same time horizon. In this example, I would like to keep the time horizon vague. It really doesn't matter. On your practice questions, you have at least a couple of problems to practice this with specific time horizons that you can actually plug in the numbers and actually calculate how much you're going to make by doing an arbitrage. But let's assume that all of them will mature the same day in the following characters. Bond A has a coupon rate of 3%. In other words, it pays $30 every year with a 5% yield to maturity. Y is equal to 5. Bond B has a coupon rate of 5% with a yield to maturity of 4.5%. Bond C has a coupon rate of 7% with a 5% yield to maturity. Y is equal to 5. In other words, if you know that all 3 bonds have the par value of $1,000, you can insert in your financial calculator $1,000 FV, future value, face value, par value. All of them have the same time horizon. You can practice that by taking, for example, time horizon 10 years, N is equal to 10. For each and every bond, you know the coupon rate. C is equal to $30, $50, or $70. So PMT, the payments are $30, $50, or $70. And Y the yield to maturity, or I/Y on your calculators, will be either 5, 4.5, or 5. And then you can ask your calculators, compute present value, compute the price of those bonds. Then you will understand how much does it cost you to buy or sell those bonds on the free markets. So how can we do arbitrage? Remember that arbitrage, you need to close a circular deal to buy low, sell high. You want to buy something and sell something at the same time simultaneously, but you want to do it in a way that you buy at a low price, sell at a high price, so you will end up making money right now at time zero, at present time. And you want to design the things that you buy and sell so their cash flows, future cash flows, will replicate each other, will mimic each other, will be identical. And therefore, once you buy something and sell the other thing, they will cancel each other. Whenever you buy a bond, you are about to receive future cash flows. You pay now, but you will receive the coupons and the future par value. Whenever you sell a bond, what it means is that you become the issuer. You sell a bond to other people, you're the issuer. You collect money right now, but you're responsible to pay the coupons and to pay the par value at the end. So how do you do arbitrage here? What exactly do you need to buy? What exactly do you need to sell? I'll let you a couple of seconds to think, and then we will solve this problem. In order to do arbitrage, you need to understand that both bonds A and C, both of them have the same yield to maturity of 5%. What it means is that if you will create a portfolio of bonds A and C, any kind of combination between them will also give you 5% return, 5% yield to maturity. It really doesn't matter if you invest 100% in bond A, 0% in bond C. 50% in bond A, 50% in bond C, 60, 40, 70, 30, 90, 10, 80, 20, whatever it is, any kind of combinations between bonds A and C, all portfolios between bonds A and C will give the investor a 5% return, 5% yield to maturity, because both of them are 5% yield to maturity. That's the first step. The second step is pay attention that we're trying to replicate the same coupon rate as bond B. They already have the same, all of them have the same par value, but we will try to replicate bond B, the same coupon rate of bond B. We will try to make a portfolio between bonds A and C with the right proportions, the right weights, to replicate the same coupon rate as bond B. Here the solution is pretty straightforward. You can see that the coupon rate of bond A is 3%, the coupon rate of bond C is 7%, so all we need is just to invest 50% of our money in bond A, 50% of our money on bond C, simply because 5 is exactly the average of 3 and 7%. In this case, if we will buy 50% of our money into bond A, 50% of our money into bond C, we will replicate the same coupon rate as bond B. And now I'll ask you the following question. What do you think is cheaper? The portfolio of bonds A and C or bond B? And the answer is the portfolio between bonds A and C is going to be cheaper. Why is that? If we're able to replicate the same coupon rate, so the portfolio of bonds A and C will give you a 5% coupon rate or $50 per year. It has the same par value of $1,000 and the same time horizon, but the portfolio of bonds A and C has a higher yield to maturity of 5%. We already saw that with a higher yield to maturity, holding everything else the same, the price must be lower. Higher yield, lower price. Lower yield, higher price. So just because bonds A and C have a higher yield to maturity, everything else is the same, the combination, the portfolio between bonds A and C will give you a lower price. Therefore, in order to do an arbitrage here, you need to buy portfolio of bonds A and C with the right proportions, 50% of bond A, 50% on bond C, in order to replicate the coupon rate of bond B. and at the same time sell bond B, becomes the issuer of bond B. Let's understand what happened here. We're buying 50% of our money on bond A, we're buying 50% of our money on bond C. So we're investing in a portfolio of bonds A and C. What's going to happen as a result? First of all, when we are buying this portfolio, we're paying a small amount of money, smaller definitely than bond B. Why is that? Because the portfolio of bonds A and C has a higher yield to maturity, 5% compared to 4.5%. With a higher yield to maturity, the price must be lower. Everything else is the same. Okay. If you buy bonds A and C, 50% of your money on A, 50% of your money on C, you will receive a 50% off $30 every year from the coupons of bond A, so that's $15, plus 50% of $70 per year, the coupons of bond C, $35 here. You will collect every year half of $30, half of $70, so 15 plus $35 will give you $50 coupons every year. Now, at the same time, you are the issuer of bond B. You are the seller of bond B. Whenever you are the issuer, you are responsible to pay to your investors the coupons, the $50. So every year you are going to collect $50 from the portfolio of bond A and C, and you will have to pay $50 to your investors simply because you are the issuer of bond B, $50. You collect 50, you pay 50. You collect 50, you pay 50. These cash inflows and cash outflows will cancel each other. That's nice. What about the yield to maturity? What about the par value? The par value, you will collect 50% of the par value of bond A, which is $1,000, 50% of the par value of bond C, which is also $1,000. So 50% here, 50% here, 500 plus 500, you will collect altogether $1,000 par values, half of the par values of bonds A and C. You collect par value at the end, but then you're the issuer of bond B. You're responsible to pay the par value of bond B to your investors, so you will pay the $1,000 to your investors. Once again, these cash flows will cancel each other. The par values that you will collect on bonds A and C will cancel out with the par value that you're responsible to pay to your investors on bond B. As you can see, all future cash flow will cancel each other. What it means is that this is a risk-free. You don't care after that. What happens now, and after that you don't care because all future cash flows will cancel each other. If they will cancel each other, you don't care, and therefore it's risk-free investment. The beauty here is that you're making positive return immediately on the very first second that you do that. Once again, why is that? Simply because the portfolio of bonds A and C are cheaper than the bond B. Bond B, if we're able to replicate the same coupon rate, and right here the solution is straightforward, just split your money evenly between bonds A and C, 50% on your money on bond A, 50% on bond C, then 50% of 3 plus 50% of 7% coupon rate will give you 5% coupon rate of bond B. Because the yield to maturity between any kind of combination of bonds A and C will give you 5% yield to maturity, higher yield to maturity, it means lower price than bond B that has a lower yield to maturity. That's why you pay low, you collect high, you buy low, sell high right now, you make positive cash flow right now, and all future cash flows disappear. This means an arbitrage. Once again, when you see something like that, you need not to buy just one bond. Don't make all of this effort to make just a couple of dollars. You can replicate this strategy millions of times. Simply because there are millions of bonds issued on the market, traded on the markets, you can replicate this millions of times and you can make millions of dollars in a matter of seconds. Right now, you make positive cash flow and all future cash flows will disappear. Here, in the following slides, you have the formal explanation and also the formal proof based on principle number 5. It's really not that important to understand the formal proof, but I do want to emphasize, for those of you who don't want to go over the formal proof here, just the fact that this is nothing beyond algebra, that we just disentangle the price of each and every bond. So the subnotation uppercase A, B, and C are bonds A, B, and C. Those lowercases a and lowercases b here represent the slope and the intercept taken from principle number 5. We saw them at slide number 56. So the slope is here and the intercept is here. And after that, it's nothing beyond a simple algebra. So after you break apart the price of each and every bond to the slope times the coupon plus the intercept, all you need is just to batch some things into brackets, and you can follow that. It's fairly straightforward and nothing beyond that, but it's not that important. More important is to understand the concept of how to do arbitrage here, which is buy low, sell high. Why the portfolio of bonds A and C is cheaper than a bond B, simply because this combination will have a higher yield to maturity, which means a lower price. What exactly do we need to buy? What exactly do we need to sell? Which is always the same with arbitrage. You need to buy low, sell high. You make immediate positive cash flow, and all future cash flows will disappear. So that's the way to do arbitrage using bonds. I will also add one quick comment here that in reality, obviously, you don't have only 3 bonds. You have thousands and thousands of different bonds. So what happens in reality is that many hedge funds and financial institutions and also private investors, they run computer algorithms to search between those thousands and tens of thousands of different bonds to search for arbitrage opportunities. So this can trigger you to think about all kinds of possibilities and the desire to look for arbitrage opportunities using different computer algorithms.